Hey everyone, this video right here, this is going to be a truss problem from statics. So I posted another video doing method of sections for trusses, and then somebody that watched that video asked if I could solve this problem because they were having problems with it. So I looked at it and just decided to make this quick video on it in case somebody else had the same question. So I don't have the actual picture because they just kind of described it in the comments, but this is what it looks like. It's just a Warren truss. We've got an external force of 50 kilonewtons here. There's 50 kilonewtons here. Pin at A and roller at E. And I'm hoping this is the correct picture that they were describing. But that's kind of how I drew it out. And then the problem they were looking for, it wanted to find the forces in BC, GC, GF, and then EF, DC, DF using method of sections. And then it also asked to find forces in BC, CF, and ED using method of joints. All right, so we'll kind of look at both of those and go through how to solve both of these problems. All right, and hopefully it won't take too long. So first thing we want to do is look at method of sections. So remember, method of sections, you have three equilibrium equations you can use, right? You got the y equation, the x equation for forces, and then you've got the moment equation. So we can only solve for at most three unknowns. Okay, so keep that in mind. Three unknowns at most for each free body diagram. All right, so let's look at this first list here. Okay, so it says BC, GC, and GF, right? So that's what it's asking for. So let's see if we can cut through this truss where we only cut through these three unknowns, all right? So let's look at that. So here is BC, right there. Here's GC, here's GF. So is there a way that I could section this and only go through those three unknowns? Yes, right? We can do something that looks like that. Okay, so that goes through those three unknowns. That's perfect. Now it also wants EF, DC, and DF. Okay, well those are totally different members of the truss, right? And you might be thinking, well, that's three more unknowns. It is, but we can just do two different free body diagrams and then solve for this one using the second diagram, right? So some of these method of sections problems, you're not just going to do one section and be done. You're going to have to do a couple of them depending on how many unknowns it's wanting. So for this one, let's look. We got EF, DC, and DF. So let's see where that is. Here is EF. Here's DC, here's DF. So if I draw a line right there, that cuts through those three unknowns. Okay, so if I do a diagram for each one of these sections, I will be able to solve for these six unknowns using those two diagrams. Okay, so that's where we're going to draw our sections. Let's label this as 1, this is 2. Now the problem is, on both of these, I got to choose, you know, the left side or the right side. Okay, now either side I choose, I've got external forces in here that I don't know, because I've got a pin at A, I've got this roller at E. So regardless of which side I choose, left or right, I'm going to have to solve for these external reaction forces. All right, so that's going to be our first step. So let's solve for A and then E. Then we'll just have it all done, and then we can pick what side we want to use. Okay, so that's going to be our first step. So let's do that first. So let's solve for our external reaction forces. Okay, so to do that, we need to draw an outline of this whole truss. It doesn't have to be perfect here, so we'll leave it like that. And then let's put these forces on here. So we got 50 kilonewtons there. I got 50 kilonewtons here. We got a roller at E, so the roller just provides that upward force. It's called EY. And then at A, I've got a pin. So the pin is going to provide a horizontal and a vertical reaction. And I just always assume those are in the positive direction. All right, whether they are or not, we'll find out in just a second. Okay, so we've got that, and now let's label our distances. on here. Okay, so notice this is 1.5 meters in height, and then in between each joint it's 3 meters. All right, so that means, we extend this out here. This distance here is 1.5, and then this total distance from A over to E is going to be 9, right? Because we got 3 plus 3 plus 3. All right, so we've got that. And then finally one more. We have this 50 kilonewtons. It's right in the center, right? So if I were to put, draw a little line up there, this length here will be 1.5. Okay, so now we got everything we need for our diagram. And remember, I'm not having to put all of the forces for each of the members in here because these are all connected together. So when they're connected together, we got equal and opposite reactions, so they cancel each other out. Newton's third law, right? Okay, so let's look at this. I want to find these 3 unknowns. Easiest equation to start with will be the moment equation, and point A will be the easiest point to use because it's got these 2 unknowns going through it. So let's do that first. All right, so counterclockwise is positive, like we always do. Okay, so here is 50 kilonewtons. So this is to the right of point A. So if I look over here and push down this way, it's clockwise, so it's a negative moment. So we got negative 50, and then that distance, 1.5. Okay, so we got that. And then over here, we've got the 50 kilonewtons. So this is above point A and going to the right. So obviously, if we had something like that, it's kind of hard for me to show you on this pen, but it's going to be a clockwise rotation here also. So that would be negative 50, and then that distance is also 1.5 right here. Okay, and then finally we got EY. So EY is going up, so if I hold here at A, push up, whoa, it's going to be counterclockwise. That's positive. So plus EY, and then the distance right here is 9, right? Because that 9 meters is perpendicular to EY. So that would be our moment arm there. All right, and that's all we got. So set it to 0, 1 equation, 1 unknown. So we can go through and solve. And we get 16.67 kilonewtons. All right, so now we've got that. And you guys check my numbers here because I just quickly ran through these calculations. So hopefully I didn't mess anything up. Okay, so next let's do the x equation. So we got ax and then positive 50 here. That's all we've got there. It makes it easy. So ax is going to be negative 50. So that just means I chose this to be in the wrong direction. All right, because I always say that these are, I just assume they're in the positive direction. That's just what I do every time. So the negative just means it's opposite, and that makes sense that it should be going to the left because I've got this going to the right. So this one here is counteracting that one. So it makes sense that it should be to the left. Okay, but I'm just going to leave everything like it is. I'm not going to change anything. I'll just carry that negative through when I use ax. All right, and then Fy. Okay, so we got Ay minus 50, and then plus Ey. All right, now we already found Ey, so let's plug in the 16.67 and set that to 0 there. So Ay, once we solve, we get 33.33 kilonewtons. Okay, so now we've got our external reactions, so that's perfect. Now we can go ahead and start doing part 1 here where we do method of sections. Okay, so first section we're going to look at is section 1. So you have to choose, left side or right side. It doesn't matter which one you choose. You might think one is easier than the other. So for this one, I'm going to go ahead and just use the left side. All right, that's just the one I happen to pick. All right, so let's just look at section 1 here. And now, remember what we're doing is we're going to just look at everything to the left of this pink line. I don't care about anything over here at this point. Okay, so I don't care about this 50 kilonewtons. I don't care about this roller. I don't care about any of this. Just what's to the left of this line, because that's the side I decided to use. Okay, so let's go ahead and draw that out. All right, so we got this. All right, so there's that full triangle. And then we're cutting through these members. So this is like cut through this top member BC, and then we're gonna cut through GC, and then we're cutting through GF. All right, so that's just showing kind of an outline of the truss there. So now we need to add our forces on here. Let's do that with the yellow. Okay, so we've got this 50 kilonewton force. We need to add that on, so that'll go right there. And then we've got our pin at A. So I'm gonna leave the forces at A looking just like this, okay? And I'll use the values that I got here. All right, so AY still going up, so 33.33 kilonewtons. And then AX, I'm still gonna put it to the right, but I'm gonna use -50. All right, so if you wanted, you could flip it to the left and make it positive, but a lot of times that tends to make students, they forget the signs and stuff, so I just leave it alone and carry the negative through. Okay, so those are the external forces. Now we've cut through these three members here, right? So there are forces in those members, right? We got tension or compression. So what we want to do is draw a force representing that. So for this top one, BC, I'm just going to draw it going out of the section. Okay. If we always draw it going out of the section, it makes it really easy to tell if it's tension or compression. All right, so in the end, if we get a positive BC, that means BC's in tension. If we get a negative BC, it's in compression. Okay, so that's why I just always draw it going out. So this member here is GC, so let's just draw it going out of that member. And then finally here we've got GF. Okay, so that's what our diagram looks like. And this is a 45-degree angle here. So now we're basically ready to solve. We might want to put some distances on here. All right, so from here to here is 3 meters, and this height, let's put it right here, I guess. That's 1.5 meters. Okay, so now we're ready to solve. So we've got our 3 equations to use, right? I've got a moment equation we can use. We could also use the force in the X and then some of the forces in the Y. So I'm going to go ahead and start with a moment about point G right here. All right, so let's go ahead and do that. And I picked this point because it's got this force going through it. It's got GC and GF. So it's got 3 forces going through it, so we don't have to worry about finding the moments due to those forces. All right, so what's left here for our moment equation, we got 33.33. It's going up, right? So that's going to be negative moment because it's clockwise. And the distance there is going to be that 3. Okay. Next, if we look up here, the 50 is going to create a moment, right? Because it's not going through G. Now this one's to the left of G, so if I take this and I push down, it's going to be counterclockwise. So it's going to be positive. So we'll have 50, and then the distance here, since this is going right in the middle, the distance would be 1.5. All right, so now we got that. And then last thing is BC. Okay, so BC, that one's also going to be a clockwise moment, so it'll be negative. And then what do we think that distance is? 1.5, right? Okay, so now we've got that. Set that equal to 0, and then now we can solve for BC. So BC will be negative 16.66 kilonewtons. And like I said, If you always draw these forces going out of the section, if we get a negative, that means it's compression. All right, so a lot of the textbooks won't put the negative sign. They'll put 16.66 kilonewtons with a C, meaning compression. Okay. All right. So now we've got that one. And let's go ahead and find these other two. Let's see. So Fx here. So we've got this one. All right, so the force is drawn in the positive direction, but the value I have is negative 50. All right, so if you want, you can put plus and then put parentheses, negative 50. And then we've got BC, which we just found. Now it's negative, right? So we're going to plug in that negative value, so negative 16.66. And then finally for X, we've got these two down here. So I've got a positive GC cosine 45. And then we've got GF. And that's positive also. All right, so now we've got that. Now, the problem here is I can't solve yet, right? Because I've got two unknowns still. So we would have been better off doing the y equation first. I just didn't happen to notice that when I started that equation. So let's do the y equation and then we can go back to this one. All right, so y, we got 33.33 minus 50 and then plus GC sine 45. Okay, so see, this one would have been a better choice, right? Because we only have one unknown. So now we can solve for GC. And if we do that, we get 23.57 kilonewtons, and that's in tension. All right, and it's in tension because it's positive. Okay, so again, if we always draw these forces going out, if we get a positive, it means tension. All right, and if you're not sure why that is, if you look at my other example on method of sections, we kind of walk through that. All right, so GC here, now we can go to this equation. Let's plug in 23.57. Now GF is our only unknown, so solve for GF. And GF will be 49.99 kilonewtons. It's positive, so that means tension. All right. So that's the end of that first section. Okay, so we found 3 of those unknowns it asked for. So it wasn't too bad, right? You just got to do this method twice to get all 6 unknowns that we're looking for. Okay, so now we're going to go ahead and we're going to find these 3 unknowns. So that's using this cut right here. So we can do the left side or we could do the right side. So just to do something different, I'm going to pick the right side this time. All right, that way you have an example of the left side and then one with the right side. Okay, I'm going to do the right side. So that means we're going to ignore everything over here and only focus on this stuff here to the right. Okay, so let's do that one. All right, so let's, wish I could fit this all on the same screen here. So let's look at this. So we're cutting right through here. So we're going to have these 3 unknowns. I've got this roller at E, and then I've got that 50 kilonewton force. Okay, so let's see, this is point D right there, and then we've got joint E. And now we got that roller at E, remember, so we got 16.67 kilonewtons coming up there. And then we're cutting through EF, we cut through DF, and then we cut through CD. And that's 45-degree angle there. Okay, so now let's draw our forces. All right, so this top member, this is CD, so we'll just put CD here. This is DF, and this here is EF. Notice again, I'm drawing these going out away from the section. That way we can use that positive is tension, negative is compression sign convention. Okay, so now we've got this. And let's put some distances on here that we might need. So, oh, and we forgot one other thing. I almost forgot. Almost forgot that 50. Uh-oh. I should have made that yellow. Okay. So now the distance here that we might need, this distance from here to here, that's 1.5, remember. Okay. So now, same kind of thing. Let's go ahead. We're going to use our 3 equations of equilibrium, and then we can solve for 3 unknowns, right? And let's go ahead and do a moment equation first. And what point do y'all think would be easiest? We got 2 choices, right? We got E, I got D. Those would be the obvious choices here. So D, I think, would be the best because it's got 3 forces going through it. All right. And just so y'all know, remember, if you wanted, you could put a point right here, like at F, and take the moment about point F also. All right, and then it would have these 2 unknowns going through it. You could do that also. That one's typically not as obvious as the ones that are drawn on the diagram, though. But you could do that if you wanted. All right, so let's just do D. I think that's a good choice. Okay, and counterclockwise, positive, as usual. So we're going to have EF down here. That is going to be a negative moment. So if we put this like this, rotate clockwise, right? So it's negative. And then its distance is that 1.5. So we got that. And then next I've got 16.67. All right, that one is going to be counterclockwise, so it's positive. And then that distance, what do we think that is? Well, if we look back up here, we're looking right here. And here is D, right? So D is right in the center. So that means it's half of 3 meters, so 1.5. Okay, so we got that. And that is basically it that we have for this moment equation because everything else goes through D. So now you could solve for EF. And what do we get? Positive 16.67. So it's positive means it's tension. All right, now let's go ahead and look at our force equations. Okay, so I'm not going to make the same mistake I made up here where I did the X equation first. Let's see which one makes more sense. So for the X equation, I'm going to have these 3, all 3 of these are going to be in the X equation. All right, so that's going to give me 2 unknowns. I don't want to do that. So let's look at the Y equation. For Y, I'm only going to have this one and then this, right? So that's a better one to start with. Okay, so now for the Y equation, we got positive 16.67 and then a negative df sine 45. That equals 0. So solve for df and we get 23.57 kilonewtons in tension. Okay, and then finally that X equation. So we got positive 50 minus EF, which we already know what that is, 16.67. We've got a negative df cosine 45. We know what df is. And then we got a negative CD. That equals 0. All right, so CD then is going to be a positive 16.66 kilonewtons. It's positive, so it is in tension. All right. So that is how you go about solving for more than 3 unknowns using method of sections. All right, if you're going to solve for more than 3 unknowns and you're only supposed to use method of sections, you're going to have to do 2 separate sections. All right, because you don't have enough equations otherwise. So there you have it. So hopefully that one makes sense, doing method of sections. And then let's kind of quickly walk through this method of joints. So it's wanting these 3 unknowns, so BC, CF, and ED. And let's kind of mark where those are here. Let's get a different color. So BC, remember, is right here. CF is here, and then ED is here. So I want to find those three using just the method of joints. Okay, so remember, method of joints, you have to go through and do a free body diagram for each one of these joints where they're connected. And the problem with method of joints is you only have two equations because we're just looking at a point, right? So we don't have distances, so we don't have that moment equation. So we only have the force equations. So you can't solve for as many unknowns with the free body diagrams. All right, so let's start writing out our joint free body diagrams. So what we're going to do, or at least what I do when I do method of joints, is I go through and I draw the free body diagram for each of the joints where the members are connected. All right, so I draw them all out, and then I look at them and see which one I want to start with. All right, that's not always the optimal, most time efficient thing to do, but that's generally what I do, just so I can see everything. So let's start at A here, and here's A. We've got the pin at A, right? So we had AX and AY, so we have to include that on there. So we've got the 33.33 for AY. AX, I'm still going to leave it going to the right, but the value is -50, so we have that. And then I've got AB right here, and then we've got AG. So I need to draw those forces, and I'm going to always draw them going out of the joint, because then we can use that same sign convention that we used before, right? So positive is tension, negative is compression. We can only do that though if we always assume they're going out. Okay, so that's A, and then now let's go to G. Let's put a G up here. So G has four members attached, so 1, 2, 3, 4. So we're just going to draw the four forces all going out, and then we need to label them. So we got AG, GF, GC, BG, and then we've got these angles here. These are 45s. All right, and then F is going to look similar, right? We got four things again. So just draw them going out, and then label. All right, so actually I called it GF over here. Let's call it GF here too. And then we got EF, we got DF, CF, and then 45s for the angles. All right, and then finally here we have E. So there's E. E's a little different, right? It's got this little roller, and then it only has two members. So let's put that down right here. Okay, and EY, that was 16.67. And then we've got the two members. We're going to draw them going out. So we got ED and then EF. All right. Now remember, ED is one of the ones we're going to look for, right? That was one of the unknowns. So that's in joint E there. Okay, so that takes care of the bottom row. So now let's look at the top part of the truss. So we get B, C, D. Let's do B. So B has the 50 kilonewton force that's applied. So we got to put that on here. And then it's got those three members. So just draw them going out. We got BC, BG, and then AB. All right, so we've got that, and then we need our angles. So this is 45, and then if we draw a little dashed line here, that's 45 there. And then let's do C and then D. Okay, so C, we've got these four members. All right, so we got CD, BC, GC, and then we've got CF here with the 45s for the angles. Okay, so last one we have is D here. So D's got this 50 kilonewton force that's applied. I'm gonna have to move this up off the screen here. And then we've got these three members. All right, so we got the 50 kilonewton force. We got ED, DF, and then CD. All right, and then this is 45 degrees, this is 45 degrees. Good thing, y'all can't see that, there you go. The good thing about this problem is we have at least 45 degrees, right? It makes it a little bit easier than if you have different angles everywhere. Okay, so now I've got all of my diagrams drawn, and let's remember what we're looking for. So let's write it up here. We want BC, CF, and ED, right? So those are the ones that we are looking for. So what I'm going to do next, what I always do on these problems, is I look for the joint with the fewest unknowns, okay? Because usually with these method of joints, you're going to have to go through and solve almost all of the free body diagrams, right? You're going to have to look at all of them, usually. So I always start with one of the fewest unknowns. So fewest unknowns in this case would be either E, or if we look up here, we have A, right? Because they each have 2 unknowns. These others have at least 3, right? B has 3 unknowns. These all have 4, and then D down at the bottom has 3, right? So I don't want to start with any of those because I only have 2 equations, right? We have the sum of the forces in X, sum of forces in Y. Those are the only 2 equations we have because we can't do a moment equation because we're just looking at a point, right? We don't have distances and stuff like that to calculate moments. So I'm going to go ahead and start with E, and if I do that, I'll be able to solve for ED. Okay, and then that's one of the things we want to find. I can also solve for EF, and then we can put that up in some of these others if we need to, and go from there. So let's start with E here. All right, so to the right will be positive. We just want to sum up the X components. So I'm going to have negative ED cosine 45, and then minus EF. Now, obviously, I can't solve for that yet, so let's go to the Y equation. We got 16.67, and then plus ED sine 45. All right, so now I can solve for ED. And if we solve for ED, plug this in the calculator, we get negative 23.57. All right, so just like on the method of sections, this is negative, so that means it is compression. All right, so there's one of our answers we were looking for right there. All right. Now, since I already have this equation, let's just go up ahead and let's find EF in case we need it. So ED we know is negative 23.57, and now you can solve for EF. And that one is going to be 16.66 kilonewtons. Now, if we look at our units, not our units, our signs, we got a negative times a negative, so that's positive, right? Then when I move it over, it becomes negative. We divide through by this negative, it becomes positive. So it's positive, so we get a tension there. And if you look at the page we had before, that's exactly what we got here, right? So same thing. Okay, so that's done. Now what I usually do is I take the results here and I put them up on these other diagrams where I might need them. Okay, so EF, this was 16.66, so let's plug that in there. And then we also have ED here, so that's down here. Now you got to remember that negative sign. Okay, so now we've got that. And then that's the only places we need to put those values. All right, so now we've got that. So now I want to see if I can get BC and CF with just, one diagram, one left, but we're not going to be able to do that, I don't think. So let's look at C right here. All right, so this one has both of the unknowns in it, right? It's got BC and CF, but it still has 4 unknowns, so I'm not going to be able to solve for that one yet. So I need to find another diagram that has 2 unknowns. All right, so let's go ahead. Let's look at D down here, right? Because now it has 2 unknowns. CD is one of them, and CD is up here also. So let's go to this one next. And let's do the y equation first. And I say that because this will be the only unknown in that equation. So we can solve for df and then get CD. Okay, so for the y equation, I've got negative df sine 45. And then we've got minus ed sine 45. And then I know what ed is, right? So I'm going to plug in the negative 23.57. And then we can solve for df. Now the value we get here is 23.57. All right, and that's going to be kilonewtons. And it's going to be positive. Again, we got negative with a negative becomes positive. We move it over, becomes negative. And then we divide through by negative sine 45. Okay, so it becomes a positive number, so it means it's in tension. That is exactly what we got right here. Okay, so that checks out. And then now let's find the x equation. All right, so we got negative CD cosine, actually it's not a cosine, just negative CD, and then minus df cosine 45 plus ed cosine 45 and plus 50 equals 0. Okay, I know what df is now. It's 23.57. I know what ed is. That one is negative 23.57. So now once you plug all this in, you can get CD. Okay, so our value here is 16.66, and this is, once you add all this up, this is a positive. We bring it over, it becomes negative, divide through by that negative, we get the positive. Okay, so that's tension, exactly what we got doing method of sections. Okay, so now I've got these two values that we can put up here. All right, so CD is 16.66, so let's put that up here. All right, and then I also know DF. Where is DF? So DF is up here. So we know this is 23.57. Okay, so now we're getting closer here. So let's see what we can do now. So I'm still looking for CF and BC, right? Those are the ones we haven't found yet. So let's look at the diagrams that have those unknowns. I still have this one, joint C, but we still have 3 unknowns. Okay, so I don't want to use this one if I don't have to. BC, still 3 unknowns right here, even though, you know, joint B has that. This one, F, has CF. Now, we only have 2 unknowns here. So I'm thinking this is a good choice to start with, right? Because I can find CF and then bring it down into here, and I'll have 2 unknowns here in joint C. So let's do this one, and then we'll go to C. All right. And I don't really need to find GF, right? I just need the CF. So let's do that. Let's use the Y equation. That will give us CF. Okay, so we got positive CF sine 45. And then we've got positive DF sine 45. That equals 0. Now I know what DF is. So 23.57. So now we can find CF. And if you notice, you're going to move this over. It becomes negative. The sine 45s cancel, so we get negative 23.57, which means it is in compression. All right, so there is CF. Okay, and now we're going to take that and we're going to plug this in to C. All right, so we got down here. Now we're left with 2 unknowns, BC and GC, but the only one I care about is BC at this point, right? Because I already found these 2. So BC is the one I care about, so that's on the x-axis. So let's just do the x equation, and we'll get what we need. All right, so we got negative BC plus CF cosine 45 plus CD. All right, and if y'all notice, even though I have these values, I always just write the variable out first, the force name, and then I plug in my values, because otherwise, if you have the negatives here, it's easy to miss out on your signs and make mistakes. So I just always plug the values in at the end. That tends to help with the signs. Okay, so this is our last one, so let's see what we get here. Hopefully we get the correct answer. Let's see. So we got that plus 16.66. And let's see. Mess something up here. Oh, y'all know what we did, or you know what I did. This GC, it has an X component, so we're going to have to include that. I forgot it. I was about to say, why am I getting the wrong answer here? So we got to put negative GC cosine 45. Y'all are probably all noticing that, being like, what is she doing? Okay, so we got this one too. So let's do the y equation now, because we're going to have to solve for that also. All right, so for the y equation, let's do GC sine 45, and then that's negative, and then we have minus CF sine 45. Okay, and then this value for CF is negative 23.57. So now if we have this, we've got negative, negative, that's positive. We take it over, becomes negative. Divide through by the negative sine 45. So then GC is going to be 23.57 kilonewtons. That's tension. And then now we can take this and plug it in up here. Okay, and then let's see if we get what we need. So I need to subtract 23.57 cosine 45. All right, so now you can see what I got. Right, negative 16 point, says 6.7, but I've been doing 6.6, so we'll stick with that. All right, and it was negative, so when we move it over, what's going to happen? It's going to become positive, but then we're dividing by this negative. So we're going to have negative 16.66. So that is 16.66 kilonewtons in compression. Okay. So that is how you can go through and solve this using method of joints. All right, so method of joints is pretty straightforward. The equations are easy, assuming you don't, mess up like I did here and forget things. But it can be time consuming because you typically have to, do several of the joints. Sometimes, a lot of the times you have to work through all of the joints to get the unknowns, right? So it can be time consuming. But that's how you do this one using method of joints. So hopefully y'all found that helpful, and I hope y'all have a good rest of the day, and I will see y'all next time for another tutorial.